Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 182. Please turn to page 182, the very first problem in the second column. And today is our lesson number 243. 243. Problem number 211, the very first one in the second column, as I just said. The question simply is, which is the equation of line L? So they're giving us a line L here. We are told that it goes through 1, 2, it goes through this point here in the picture, precisely. And it goes through, at the bottom it goes through 3. 1, 2 and 3, it goes through here. That's our line L. And the question simply is, of the 5 equations that they give us, which is the one that describes this line? Well, let's see what we can do. The simplest and the easiest way to tackle this problem, you could actually write each one of these things. Look, here is the first answer, 2x minus 3y equals 6. We could actually figure out, waste our time trying to come up with the equation of this line, which can be very easily done with the slope and we know the slope, we know at 1 point it goes through, or we know 2 points, whatever you want to call it. We can actually precisely figure out the equation of this line and then see which one matches the equation that we arrive at. That's one way of doing it, which is more of a traditional way. Another way is to simply realize that we know the two intercepts. We know the x-intercept, we know the y-intercept. At the y-intercept, x is 0, y is 3. Here, x is 3 and y is 0. I think this is 2. 1, 2. That y is 2. That's important. Otherwise, we'll mess it up. We have to pay attention. So that's what we're going to do here. Let's put in x equal to 0. If you put in x equal to 0, we end up with 3y equals 6, which means y equals negative 2. When x is 0, y is not negative 2, y is positive 2. This one describes a point. This one describes the points down here. When x is 0, y is negative 2. The line does not go through that point. This is 0 and negative 2. The line does not go through this point. Line goes through 0 and positive 2. A is not the answer. Let's look at B. B says 2x plus 3y equals 0. Well, it equals 6. Again, when x is equal to 0, we plug in x is equal to 0 and we get 3y equals to 6, which means y is equal to 2. Now that does the job. Y is equal to 2. So that's the possible candidate. That does not necessarily mean that's the right answer. It just means that we cannot rule out B. So let's keep B. Let's go to C. Let's go to C. C says 3x plus 2y equals 6. Again, if you put in x equal to 0 here, we end up saying that 2y equals 6, in which case y would equal 3. Y does not equal 3. Y equals 2 when x is 0. C is not the answer. Let's look at D. D says 2x minus 3y equals negative 6. Again, when x is equal to 0, we will get the negative 3y equals negative 6, which will give us y equals to positive 2. That does the job too. So D is a possible candidate. Let's look at E. E says 2x minus 2y equals negative 6. That will give us, when x is equal to 0, 2y equals negative 6, or negative 2y equals negative 6, which will give us y equals to positive 3. The y-intercept is not positive 3. The answer is not E. So it's either B or D. So we eliminated 3 answer choices just by looking at the y-intercept. Now we're going to look at the x-intercept, and that will help us eliminate the remaining one. That's all. So now it's time to look at the x-intercept. Let's start with B. B says 2x 2x plus 3y equals 6. So So we're looking at x-intercept where y is 0. So 2x equals to 6 because y is equal to 0, x is equal to 3, which is precisely what we find here. So that's your answer. That's our answer because D cannot also work, because if D also worked, we'll end up with 2 right answers. Let's find out, let's confirm it. D cannot work also. 2x minus 3y equals negative 6. When x is equal to, when y is equal to, when y is equal to 0, when y is equal to 0, 3 times 0 would be 0, and we'll get 2x equals to negative 6 and x equals to negative 3. X does not equal to negative 3, x equals positive 3. This one is describing a point over here. 1, 2, 3 is describing this point. So as you can see, D does not work, answer is B. So that's how you do it. You eliminate 1 or 2 answer choices, perhaps even 3 answer choices with one intercept, x or y intercept, it doesn't matter which one you start with. And you eliminate the rest of the remaining for whatever it is until you narrow it down to 1. That's what it is. You don't actually have to find out the equation of the line. Let's do the next one, shall we? Let's do the next problem. The answer to this one is B. In the next problem, problem number 211, they say, or rather 212, they say digits of 2-digit integers are reversed. As a result, the new number obtained differs from the original one by 18, or rather, sorry, I gave it away, didn't I? Oh, blasted. By some amount. By how much do the digits differ? Let's first understand the question here. So in the book as it is stated here, I'm going to read it to you. It says, number 212, it says, if a two-digit positive integer has its digits reversed, the resulting integer differs from the original one by 27. By 27. How much do the two digits differ? By how much do the two digits differ? Let's first understand the question, shall we? For example, if we have a 92, that's a two-digit integer. 92 is a two-digit integer, obviously. If you reverse the digits, 92 becomes 29. 92 minus 30 would have been 62. 92 minus 30 would have been 62. So this is 63. As you can see, this problem would read as had the answer been 92, or rather, had the answer been 7 to this question would have read, digits of two-digit integers were reversed. As a result, the new number obtained differs from the original one by 63. And then the question would have been, how much do the two digits differ? The two digits differ by 7. In that case, the answer would have been 7. That's how much they differ. The question is, how do we go about setting it up? In other words, how do you express a two-digit number in the language of algebra? That's the biggest hurdle for most people. For example, if we have a number, let's say if we have 54, how do you express 54 in the language of algebra? Let's pretend that x is equal to 5 and y is equal to 4. Okay? We have two variables here, x and y. Do we simply write this as xy? No. xy in the language of algebra would mean 5 times 4. That's what it means in the language of algebra. xy does not mean 54. We cannot just write that as xy. To express 54 in the language of algebra, we have to write it like this. 54, listen carefully. Oh, I shouldn't have erased this thing. X equals to 5, y equals to 4. 54 is so called because it is made up of 54 is so called because it is made up of 50 and a 4. That's a startling concept. 50 and a 4. Now here our x is 5. How do you express 50 using this x? Well, that's 10 times x. That's 10 times x. 10 times 5 is 50. Plus 4, which is our y. Voila. This, in the language of algebra, is 54. If x equals 5 and y equals 4. That, in the language of algebra, is 54. On the other hand, if you tell me that a equals 6 and b equals 2, if you want to write 62, you write that as 10a plus b. Now that, in the language of algebra, is 62. Because 10 times a would be 60, 10 times 6 is 60, plus a 2 will give us 62. This thing is 62. Now what happens when you reverse their digits? So the number that we're dealing with is this right here, 10x plus y. Or if you like, a and b, or u and t, u for the unit digit, t for the 10 digit if you like, it doesn't really matter. So here we go, 10a plus b is our original number, where a is the 10th digit and b is the unit digit. Tell you what, just to please you, just to make you understand that these letters have actually no meaning at all. These are just names that we assign to the unknown variable, to the unknown quantity, so that we can talk about them, so that we can manipulate them. The names have absolutely no meaning whatsoever. Why don't we christen them? I'm going to call this thing T, because it's easier to remember. T, where T is the 10th digit, and U would represent our unit digit. Now what happens when you reverse it? When you reverse it, 63 becomes 36. So if 63 is to be expressed as 10 times t plus u, because t equals 3 and u equals, because t equals 6 and u equals 3, then 36 would have to be expressed as 10 times u plus t. This is the same number being written in the reverse order, in the reverse digits. And that's your new number, which is 10 times the unit digit plus the 10 digit. And we are told that when you take the new number and subtract from it the old number, we are told that they differ from the original by 27. The new number that we obtain, which is this number right here, this is our new number. This is our new number. This is our original number. And they differ, we are told, by 27. I'm going to erase everything here because it's getting too crowded. It equals 27. That's it, we're done. All we have to do is look for their difference. So let's do it. So it's 10t here, I see 1t over here, and I see a minus sign. So here we get 10t plus u minus 10u minus a t, which we are told is 27. As I said, 10t minus a t is going to give us our 9t, and then u and a negative 10u is going to give us our negative 9u, and we are told that equals 27. Divide the entire equation by 9 and you find that t minus u equals 3. Voila. Oh, I didn't mean to do this thing. I was going to do a different problem. I wasn't quite paying attention. Quite inadvertently, I actually ended up doing the problem that is in the book. I wasn't going to do that. I was going to make you do the problem yourself. Blasted. So that's it. The question was, how much do the two digits differ? The answer is, they differ by 3. They differ by 3. And therefore, the number that we're looking for, there is no unique solution here. Do you understand? All we know is that 2 digits differ by 3. And what are the possibilities? What could the numbers be? Well, let's take a look at it. The numbers that we're looking for could be, the number in question could be 41. In 41, 4 minus 1 is 3. You see, the 10 digits differ by the unit digits. 10 digit differs by the unit digit by 3. I don't know, I'm not saying it right. 10 digit and unit digit here. 10 digit and the unit digit differ by 3. Right here we said it. Therefore, you will find that 41 minus 14. If you were to reverse the digits, you will find that their difference is exactly what we are told here. This will be 27. That's one possibility. There is one possibility. Another possibility is that maybe it is, instead of 5 and 1, it is 5, instead of 4 and 1, maybe it is 5 and 2. These two digits differ by 3. Again, you will find 52 minus 25 is also 27. That's one possibility. There are several possibilities. Another possibility is perhaps it is 63 and 36, or maybe 74 and 47, or maybe 85 and 58, or finally maybe 96 and 69. All of this in all of these scenarios, you will find that they differ by 27 exactly, just like the problem tells us. That's it. We are done. The answer was, question was, how many do the two digits differ? They differ by 3. What I want you to do for tomorrow, since as I said, I ended up doing the problem that I was not going to do today. Inadvertently, I ended up doing the problem that is in the book. So I'm going to give you the problem that I was planning to do today. It's the exact same problem. Nothing changes here. Once you understand the concept, once you understand what's going on here, this problem should go like that. Like that. Look, instead of 27, we're just going to make it 18. It's so simple that it's silly for me to say that we'll do it tomorrow. But it's anyway. You take care of it. Well, I'm going to pick it up from here in the next video. Okay? Let me erase the part that does not. We'll worry about it tomorrow. I'll see you tomorrow. Okay? Bye now.